Okay, Assalamualaikum. Now we continue the discussion for tutorial chapter 1, matter, hour 7, number 29. Okay, reaction between copper oxide and nitric acid produce copper nitrate and water. The amount of copper oxide and nitric acid is given. The reactant, copper oxide and nitric acid. Determine the limiting reactant. What is limiting reactant? So refer to your notes and you need to remember this term. Limiting reactant is completely consume and limit the product. Completely consume and limit the product. And then B, write the balance chemical equation. So the balance chemical equation is like this. This is only the inspection method. Must balance. So after balance, determine the limiting reactant. So the reactant is here. Limiting reactant must be either one, copper oxide or nitric acid. So you need to know how many mole of copper oxide and nitric acid given and compare with needed. So the given is here, amount of copper oxide, mole of copper oxide, and then mole of nitric acid also can be calculated. So 0.0879 mole of copper oxide and 0.01 mole of nitric acid. This is the given mole. So this mole must be some mole become acid and some become limiting reactant. So we can for example here I choose copper oxide for one first. Okay, copper oxide react with 2 mole HNO3 in from equation. This is from equation. 1 mole of copper oxide, 1 mole and 2 mole HNO3. This is the complete reaction. So if we have from the given mole is 0.0879 mole copper oxide, so how much nitric acid should we need? So here, because it is like 2 times, so copper oxide must be nitric acid must be 0.178 1758 mole nitric acid. This is a needed mole. So needed mole we need to compare with the available. So we can see that the available is less than needed. So that's why we can conclude nitric acid is limiting reactant. And nitric acid is limiting reactant. Okay, sometimes we can get excess first, and sometimes we directly can get limiting reactant. So for this, we can get nitric acid directly as limiting reactant. If we change 2 mole HNO3 react with 1 mole CuO, maybe we can get first copper oxide is excess. Okay, so limiting reactant is HNO3 limiting reactant. So the mole for product will determine by the mole of limiting reactant. Okay, so what is the mass of excess reactant after the reaction? How much excess reactant? How much copper oxide excess after the reaction? After all nitric acid become product, how much copper oxide left at the reactant side? So we must know how much copper oxide react with nitric acid. So nitric acid is 2 mole and copper oxide is 1 mole. This is from equation. So the available nitric acid is 0.1 mole. So what is mole of copper oxide react with 0.01 mole nitric acid? So we from the stoichiometry we can get the mole of copper oxide should react is 0.005 only. And then we can compare with the mole available and minus the available one minus with the reaction with nitric acid. So we can get the unreacted mole. This is unreacted mole. So the unreacted mole is the excess mole. So the mole change to mass, we can get 6.6 gram excess reactant copper oxide. Okay, number 30 from the reaction. Determine first the limiting reactant. And given 255 gram copper oxide and 180 gram copper sulfide. So what is the limiting reactant? From these two reactant, which one is limiting reactant? so normal. Just we change the mass to mole for both reactant. So copper oxide is 1.781, copper sulfate is 1.1330 mole. This both is available. Again, available. Okay. So from the equation, 2 mole of copper oxide react with 1 mole copper sulfide. This is from equation. If we have 1.781 mole copper oxide, this is from available copper oxide. What is the mole of copper sulfide should have? This is needed mole for copper sulfide. So copper sulfide must be 0.891 mole. So here we can compare the mole needed and the mole available. We can see that mole of available is more than needed. That's why copper oxide is excess. Copper oxide is excess. So sorry. Copper sulfide, mole of copper sulfide available is 1.13. Mole of needed is 0.891. So mole of copper sulfide here is excess reactant. So copper sulfide is excess. If copper sulfide is excess, so the limiting reactant should be copper oxide. So from here you get excess first, and then you can get the limiting. Okay. Calculate, and then B, the mass of excess reactant remain. Calculate the mass of excess reactant. Same like question 29. What is the excess reactant remain after the reaction? So how much excess reactant after the reaction? So we can determine how much copper the excess reactant react with limiting reactant. Mole of excess is 1.3. Mole of mole of excess is 1.3 minus reacted mole is 0.819 equal to 0.329 mole. So excess is change the mole to mass 38.07 gram. Okay, just minus the mole available with the mole react with copper oxide. So we can get the mole of unreacted copper sulfide. Change the mole of unreacted copper sulfide to mass. Number 31. Okay, reaction between aluminium and HCl. From the reaction below, the reaction is already balanced. 0.355 gram aluminium and 20 milliliter of 4 molar HCl. So from both reactant we can calculate the mole. First, determine which one is limiting reactant, aluminium or HCl. So as usual, calculate the mole for both reactant. Aluminium, from mass change to mole, divide by molar mass 0.0131 mole. And then from HCl, from the molarity and volume change to mole, mv per 1000, 0.08 mole. This is also the present or available mole for both reactant. So from the balance equation, 6 mole HCl react with 2 mole Al. Compare HCl with aluminium. Either one, you can arrange it. 2 mole Al with react with 6 mole HCl also. Okay. And then if HCl have 0.808 mole from available HCl, how much aluminium should have? So 0.08 times 2 divided by 6. So the answer is 0.07278 mole of aluminium required. So if from here required, we can compare with the available one. 0.02 and 0.01. 0.02 is more than 0.01 present. That's why we just can conclude directly aluminium is limiting reactant. Aluminium present is less than aluminium required. So Al is limiting reactant. And then if the percentage yield of hydrogen is 85%. This is a question for percentage yield. 85% percentage yield, calculate the actual mass of hydrogen obtained. So we can calculate from the equation the theoretical mass. How much hydrogen will produce from this reaction? So hydrogen is part of product. Product will produce refer to mole of limiting reactant. From here, mole of limiting reactant we already calculate here is 0.08 mole. Sorry, mole of limiting reactant is aluminium is 0.0131 mole aluminium. So how much mole of hydrogen? Using the stoichiometric ratio, 2 mole aluminium will produce 3 mole hydrogen from the balance equation. Will produce 3 line 2 means will produce 3 mole H2. If the aluminium, how much aluminium available there? 0.0131 mole aluminium. So how much mole for hydrogen should be 0.0197 mole hydrogen. This is the mole of hydrogen you should get, and this is a theoretical mole. Change the theoretical mole to or if you don't want to change, you can just use it, or also you can change to mass. Okay. So mass of hydrogen 0.0197 mole, change to mass times 2 because hydrogen H2. So theoretical yield is 0.0394 gram. So this is theoretical. How much actual? So using the formula, actual yield divided by theoretical yield times 100, percentage yield is given 85%. Actual yield you don't know. Theoretical yield 0.0394 gram times 100. So the actual yield is 0.0335 gram. This is the formula of percentage yield. Okay, number 32. Reaction of magnesium and HCl is given. The data from reactant, magnesium 1.46 gram, HCl 160 milliliter of 0.5 molar HCl. Determine the limiting reactant as usual. So limiting reactant, you must know what is the mole for both reactant. Change the mass to mole and the volume and molarity to mole. For HCl, using the molarity and volume. From magnesium, using the mass of magnesium. So HCl is 0.08 mole, magnesium is 0.06 mole. This both mole is mole available or given in the equation. So from equation 2 mole HCl should react with 1 mole magnesium. If you have from the equation if you have from the data 0.08 mole, what should magnesium mole for magnesium? So mole for magnesium should be 0.04 from the if you use the ratio from the valence equation. So this is mole needed. So we can compare magnesium and mole available. 0.06 is mole available, needed is 0.04. So mole available is more than needed. That's why we can conclude that magnesium available is more than magnesium required. So magnesium is excess. So if magnesium is excess, that means HCl is limiting reactant. Calculate the percentage yield if 672 milliliter of hydrogen gas is obtained at STP. What is percentage yield? So 672 milliliter of hydrogen gas obtained. This is the actual value. So we need to determine what is the theoretical value from the equation. Okay, how much hydrogen gas should produce from this reaction? So hydrogen gas is the reactant. Reactant must compare with the mole of limiting reactant. So mole limiting reactant we already know. Limiting reactant is HCl. So HCl here we already count the mole. The mole is 0.08 mole. So from the equation, 1 mole HCl will produce 2 mole HCl will produce 1 mole H2. If 0.08 mole HCl, mole H2 should be 0.04. So this is mole of theory. Change the mole to volume of gas in STP. So the mole times the volume of gas at STP is 0.896 liter. This is the value for at STP. For theoretical value. Volume of theoretical value. So you already know the actual value from the equation and theoretical value from the calculation. So we just use formula. Percentage yield is actual divided by theoretical times 100. So 672 is in milliliter. Make sure you change it to liter because here is in liter. 0.8696 is in liter. Either one lah, but you must calculate in the same unit. Okay, so both is in liter. So determine the percentage yield. So the percentage yield is 75. So that is for hour 7.